My name is Jenny Oshima. I'm in charge of like a technology side at NEC SDN department. So the first of all, this is what IXIA testing is going through right now. But I'm going to start with our product overview with the web GUI. So I'm going to show controller GUI from here with the physical topology and logical topology. So the first test case, I'm going to go with the service chaining. But before I go into more detail, this is our product. When you connect our controller to the OpenFlow enabled switches, this is what we detect the physical topology automatically. So I have a spine and leaf switch fabric in here. These are the NEC switches, and this is NoviFlow, and this is Dell. Dell switch is in spine right now. So if I click here, you can see some numbers in there. That's the switch identifier for controller to recognize which switch I'm going to talk. So it's a unique identifier you can see from GUI and the CLI at the same time. So on the physical side, this is IXIA. IXIA, I have two IXIA tools running on, but first test case I'm running, the IXIA is on the OpenFlow fabric. So the client here, and then server is here. So the 100 users are sending the 100 HTTP request is happening in the OpenFlow fabric. And there are appliance pools around here. That's the service nodes. So
was this diagram statically generated or was it built dynamically?
So this physical topology, it's automatically generated. On the physical port, if you click on the switch, you can
so it looks like a normal JPEG, but you have logos on there of the vendors and things like that. So it's just an interesting.
I thought I was looking at a slide, so I saw you hovering. Wait, that's a lie.
So you can do this. What happened is this is a web GUI. So I injected JPEG file in there.
Okay, so it's sitting as a background JPEG, just to.
Right. But if you bring up all the switches, first thing you are gonna see is switches and then link. Spine and link.
So the link on the spine switch indicated 10 gig, so it will show up in the topology, right?
Right, it's 10 gig. And then it's going to show in here. So I clicked the one switch, it's going to show all the port, how, what it gets connected. So, for example, I am clicked the NEC switches here, and then I have two ports are connected to the spine switches. So if you see here, 49 is connected to the Dell switch. 50 is connected to the 10 gig IBM switch. So all the ports maps, it's going to show on the one GUI. It's just to centralize the control point. Something goes wrong, then you can find the ports from on this GUI.
So I'm curious about your GUI. Does it run HTML5? Does it require Flash or Java?
It's the combination, JavaScript, Java, HTML, all the web related the application software.
Java. No Java. Yeah.
Server is Java, yeah. So yeah.
Just not in the desktop. I don't have to install that Java.
Oh, you don't have to because it's a web GUI. So the web GUI is dynamically pops up. Yes, it's a thin client, right? So that's the thing, and then I'm gonna check the virtual topology. Just let me go to that slide quickly. So you saw all the virtual physical topology in here, and what we enable the service chaining is from defining the virtual side of the network. So either GUI or CLI, sometimes you can enable all the virtual network from the REST APIs. From here, this demo, I'm going to show from the CLI. So what you do is you define the virtual network. This is our VTN technology. This is a virtual component to map to your physical port. So here is the Ixia tool to send the traffic to the server. So this one maps, this virtual component maps to the physical port. If you see here, client and server, they are located in the different subnet. So this is layer 2 component coming from this subnet, and this is the other subnet to coming from the other layer 2 component to coming from this subnet. So in here, I have a layer 3 virtual component. So what we do is, in our controller, we do the virtual routing. So no matter you have the different subnets, we make the route each other. So once we define these virtual components, what about the service nodes? Service node is regarded as the one virtual component in our the virtual network definition. So I have 3 service nodes defined as a node. So from here, I can make the traffic go through from client to server, but before I go to the server, on the way, I can make this traffic go through the individual service node. So that's what we do, virtual redirecting the packet. When packet comes from here, we redirect to the other virtual interface, virtual component. So no matter how many your virtual, the network component in our controller, we can redirect anywhere you want. So this is one way we do. So I'm going to show logical topology on this VTN from the GUI.
And the important point of that is that the service is location free, so that even if a VM moves or the service moves, the policy is still intact.
So if I was to migrate a VM from, this Hyper-V instance to this Hyper-V instance, you would know about that and the flow would move with it.
The flow would still apply the correct policy.
Right.
So is that done preemptively? In other words, you populate all of the policies everywhere first, or is it done by the first time something comes in from that host, you ask the controller, you got anything for this host, and it goes, oh yeah, here's a bunch of policies.
Yeah, so it's real time delivering that. There are certain policies that are set up in order to manage the original broadcast, and then from there, the what we're going to be showing is going to be.
So it's an as needed policy push, not a flood everywhere and cover it. Okay, good.
This is like a virtual map when you define through our controller. So this is a Ixia client, 100 requests comes in, and then these are the service nodes. So if I go, since I'm generating traffic, I go here, then you can see the flow basis traffic going from the client to server. So I didn't enable the service yet. So let me enable the service one by one. So this is a CLI example I'm going to show. So I'm going to enable the Redware first. So this is like a CLI type of interface, but it's like a template. So it has like syntax into it, but it's not that difficult to understand. We give away all these templates for for you to write another logical programming in our controller. So right now I enabled the redware. So what it happened is, so to either physical logical, it's going to show both, but let me quickly show, physical side, it's easy to see. Traffic is going to go through here, where the redware device is located. So traffic is going to go through from here. Hold on. So from the XCI client to the redware devices. And then next flow is going to be from XCI device to go to the server. So meantime, I enabled this one service node on demand, dynamically. Meantime, XCI tool, there is no packet drops. So there is no packet disruption. This is what we passed. So XCI is going to show there's a retry, timeout, the counts. So that we sent the 100 request and then we enabled the service dynamically, but there was no traffic disruption. So if I enable 3 other the nodes, let me keep going on. Then traffic is going to go through all those services. But there is no traffic disruption still. So I enabled all the services.
If there's dual appliances, if it's load balancers or what have you, is there any issue with the service chaining? So do you support an active standby cluster for load balancing or firewall and whatnot?
Definitely. So you can set the load balancer and firewall like an active standby, and there is like a virtual IP or the virtual MAC. That's what we keep. So if one the load balancer dies, then inside the load balancer mechanism, failover is going to take over to the other the unit. Then that's what we pick up.
Do you have to reprogram a flow out the port the standby connects to?
No, we don't. Because from the beginning, you are going to have 2 physical ports. So we are going to recognize 2 physical ports. And then the load balancer logic is going to, if one port fails, it's going to go to the other ports. So we are going to continue to work with the other port. So the inside here, physical, it's going to show 2, but the failover happens, it's on the appliance side of function. Yeah. But in the other case, if there is no active failover functions in your network, we have other mechanism to do that. I can go there before we move forward. Is it okay?
No, let's continue on here and then we'll go forward. But that was one of the requirements for the ONUG testing, was to be able to show a failover detected by the network service.
Okay, cool.
More typically, our customers are deploying, they have their set of services and those have their own HA capabilities.
Right.
And they're using those.
Okay.
So you see that there was no disruption, and then the traffic is going to go through redware and riverbed and the F5. So if I just refresh the traffic, then that's going to show.
So the web UI is showing all the flows that are in the network, and then we can filter based on any of the 12 tuple characteristics to identify individual flows.
Yeah, so this is we go redware first, and the next is going to be riverbed. Riverbed and firewall is in the same physical port, because this redware is a physical server, so we have 2 ports, but the riverbed and firewall, we have a virtual version, So the virtual, it's on the VMware, but the VMware, that port, physical port, is just only one port from our side, and traffic flows through that physical port. So you are seeing the redirectional arrows in there. So this is finally F5 goes through the to the other switch fabrics to get to the HTTP server. So that's the first test case, and second one was so link failure. So in this use case, we have two test cases. So one is the physical link failure. So when your appliances are connected to our switch fabric, what if the link goes down? Then for us, there is a way to make it available. So it reroutes the traffic to the another available path. So this is what it does. So my link towards the switch, it goes down, then the traffic is going to
happens is all traffic going to and coming from, let's say, a service, going over the same Dell core switch or whatever primary spine you want to use, or is it load balancing across both uplinks?
Oh, it does the ECMP. So for us, within the switch fabric, yes, it does load balancing based on the MAC and IP or port combination. So the controller gives the program for the congestion control, and what it happens is even if it does the ECMP in our logic. What happens is we do have the virtual port concept. So what it is, the traditional virtual network, the switch network. If link fails, the spanning tree is gonna rebuild all the trees. So it's gonna take time, and then there might be packet loss. But for us, we don't use the spanning tree at all. And then what we use is controller computates all the possible path beforehand. So I'm going to show the example inside the switch directly. But what it does is this port and this port is going to be the one group. It's kind of like a redundancy group. So one fails, then switch automatically knows to send out to the other path.
You have flow entries in the table. It says send it out this port. If the port goes down, switch down to a double set of entries which say send it out that port.
So for the controller side, it's going to be the virtual port of this switch to interact. So and then switch has two physical ports.
In the virtual port group.
Right. So the switch, in example, it's a 49 and 50. Switch has this group. So, and then, 49 ports goes down, then it's going to be 50.
Yeah.
And 50 goes down, it's going to be 49. Yeah. What if there are 4 spine switches, and then it's going to have like a 4 link, right? And there is a master port, and there's a slave ports for 3. So the switcher knows it always uses right.
You don't have to program each flow individually. The controller doesn't have to intervene. It just send it out this port. If that's not available, then choose one of the others.
Right.
One or more others.
Switch does.
Yeah.
So the controller role is to define the virtual group to tell the switch that here's all my ports in one group, and then the intelligence go to the switch to decide where to send when in case of link failure, right?
So switch picks up the other available ports.
When you mentioned the master port and slave port, are you referring to per flow or generally speaking on that leaf switch?
It's gonna be the generally speaking in the switch because the flows are gonna go the whatever available ports at any given time. Yeah, at any given time.
So what's the concept of master port or slave port? Is there like some sort of process that happens, or are you just saying that port 49 is always going to be the master port 'cause it's the first port in the group?
Oh, that's what. Yeah, it has. Yeah, switch is instructed like that. So if I see the switch details, let me go there in the switch and then show directly what it means.
Yeah, the OpenFlow services port group, and so we're utilizing that port group function in OpenFlow. And the PHY is actually sending a message saying to the OpenFlow process saying, hey, I have a down port.
So if we wanted to write a policy that pushed stuff up to the spines, I'm not sure why we'd want to, but we would reference the port group as the next hop, not
Physical port.
right, not the physical ports.
Actually, the controller's going to take care of that. We're going to write a policy that says FTP traffic, take this path. And then the redundancy failover is going to be handled by the controller. So it's not a device by device. It's going to be a policy across that.
So if I show here, I have a spine port 49 and the 50. So slide is wrong at this point. So this is the Dell switch and this is the NEC switch. So 49 and 50, and I go to switch in here, and then I see the, this group detail, then it's going to show my group, I have 49 or 50.
So just real quick though, is that master port, slave port a real thing, or you were just mentioning those terms? I'm just curious.
Oh, it's our internal term on the switch logic.
So whichever port is forwarding traffic, you just call that a master port.
Right.
Okay.
Mm-hmm.
But they're both forwarding traffic.
For different flows.
So one is active. It's
Per
all
flow, per flow.
Yeah, it's all active. So both ports can be used, but in terms of that particular flow, there should be.
So is there a command to show which port is forwarding for a given flow?
If you see here, yes. So we have the flow details in the GUI. So let me just disable all the service chaining first to make it simpler. So I go here. This is exactly what I'm going to do because this flow table is going to show what is the active flow for now.
Jason wants the CLI.
Oh no, I'm fine either way.
He'll take an API.
Exactly.
The traffic is going to show it's a hop by hop. So this request is going to come to which port is going to go. It's going to show. So once I identify, then I'm going to shut down that port. So in here, I can filter ingress port. So this is it. So if I click here, so this is a hop by hop, what I'm showing here. So this is going to go, ingress is 7, and the egress to go to the spine is 50. So this is going to 50. And then next one is going to be this port. So for me, I saw in the switch, 49 and 50 are the same service, the same group. So I'm going to shut down port 50.
So you can see time to troubleshoot.
Yeah, no, it's cool to see in a hop by hop, where it's going, especially in a you know, if you have 4 spines or, you know, X number of spines, it gets harder to.
And ECMP, then identifying where exactly the traffic is.
So I'm going to shot port 50. I'm going to shot, and then I'm going to see what was the switch details. So in this group, 50 is gone. So what it says is, okay, use 49. That's what switch picks up and send it immediately to the 49. So if I see the GUI, so what I'm going to show is it's going to go through the 49 instead of the 50. And I'm going to show the IXIA, what it shows. There's no traffic disruption because it happens in a microsecond level.
Again, the controller doesn't have to react to that link going down. It's already been programmed that if this link goes down, you've got somewhere else to go, and this is where you're going to go. So again, you get microsecond. You pre-programmed an alternate path. Yeah.
So you can find from per flow, per switch, I think, let me check the IXIA. You know, look at this. IXIA, there was no drops, right? No drops. So it's just GUI is slow. Just believe me.
My next question is there really no drops? I mean, because anytime you interrupt a link, there's potential to lose something that's in flight.
So that's we are better than the legacy switch fabric. So for us, that pre-populated decision is going to be on the switch. So the switch just forward whatever available path that controller programmed. So that's going to happen, you know, like a microsecond level of the decision. So for example, in this case, yeah, there's no drops. But the real case, if you pump out like 14 million packets, then maybe like a 14 packets drop. So if it's a UDP, you know, you can ignore definitely. If it's a TCP, then you resend, right? So, yeah, real case example is going to be that. So,
To be fair, we are also going into the CLI and issuing a shutdown command. So it's not like we're waiting on timers to determine that a link.
No, it knows
Right.
this event just happened, right?
Yeah. So it's an immediate link down notification. There's no pause for a physical failure and carrier detection or something. So that'll help with the lack of drops as well.
Okay, this is a couple of the 10 test cases we did for the NSV testing, but it gives you some sense of sort of the rigor and the usefulness of the testing. Really, I think illustrating that this is very much maturing and becoming production ready type solution.
Yeah. I'm pleased to see it, to be honest. I'd like to see this stuff happening. Not that it makes you buy it, like it's not a trigger, but it's part of the decision-making process to see these things proven out. That's what I'm like. That's what I like about the whole thing.
So when the appliance servers don't have the active failover, this is how we monitor the service node. So if normally I have 2 appliance servers here, and then if this server dies, and we can pre-program to go through the other available servers.
You're just polling the device or ICMP or something like that?
Exactly, yeah. So if the NIC is not available, then go to the other available servers. And then if 2 are not available, then just go through the between client and server.
Got it. Okay. Cool. Thank you.
If there is an alternate path programmed into the switch already, does that take up switch hardware resources?
I don't think so. They have, how many ports do you have? It's going to be very minimal because we have just only like a group table concept into the logic. How many bytes? It's like several bytes of the contents in the memory.
So the alternate path is part of an individual flow entry. It's not like you have to make a separate set of flow entries that are going to eat up TCAM.
No, it's not going to do that.
Okay.
Yeah.
Right. It sounds like you can have 1,000 flows using one of those ports, and then a couple of entries saying if that goes down, use this. If this goes down, use that.
Yeah.
It's a matrix, yes.
Yeah.
Minimal impact.
Yeah.
Because that was I had that same concern initially. I was like, oh, we just doubled the size.
Yeah, one of the keys to our approach is to be able to consolidate flows in the core of the network. So ingress, egress has flows on a per flow basis. In the core, it's consolidated.
Yeah, you can summarize them up like MPLS.
Yeah.
Outside of the MPLS, you have MAC tables and per flow entries per each MAC address, per each IP address. But in the MPLS, you'll have hundreds of subnets stacked into one tag. It's exactly the same. That only takes up one TCAM entry. Right. It's just NAT on or compression. Your flow compression, we do it today. It's called MPLS. Right. So what's the difference?
Yeah. I know it was a bit difficult on this demo with the screen size, but the flow visualization stuff, I seem to recall liking that last time as well. Last time we saw this. That's very handy. As someone who has spent much time in the past with ECNP doing show MLS IP exact path, putting stuff in to figure out exactly which link it went over. It's that's a nice feature.